everybody, and welcome to today's Strategic Farming Let's Talk Crops program. Happy that you joined us today for today's session, and it's called Can We Store Carbon in a Production Ag System and to What Benefit? These sessions are brought to you by U of M Extension and the Minnesota Soybean Research and Promotion Council and the Minnesota Corn Research and Promotion Council. I'm Liz Stahl, Extension Educator in Crops. I work out of the Worthington Regional Office, and today we have joining us Dr. Anna Cates. She's our U of M Extension State Soil Health Specialist, and Jodi DeJong-Hughes. She's our Extension Educator in Water Resources and Soil Health. So with that, I will turn it over to Jodi, and she's going to kind of lay the groundwork a little bit, give us a little bit of background on carbon, and yeah, get us kind of all on the same page here. So Jodi.
Hi, thanks Liz for having us here. Anna and I are working with the corn growers. They wanted us to go out and help farmers understand a little bit more about carbon and touch on the markets as well. And so I just got a few slides to kind of set us up with carbon, because this is kind of a new topic for most people. You've been farming carbon your whole lives, but we just didn't call it carbon. We call it organic matter. So why is carbon even important? Let's just start with the basics. When you look at Earth, the thing is that carbon is the glue or the duct tape for all life on Earth. It is one of the most important elements. You know, you got hydrogen, oxygen, and carbon. Those three are just everything. And then when you go down now to a different scale to soil organic matter, a lot of that is carbon, and I'll talk about that in a second. When you have higher carbon levels in your field and good organic matter levels and soil health, you actually have a more resilient field where you have less highs and lows, and your field is better able to capture rainfall, deal with drought. You can kind of bang it up a little bit and it bounces back better. And with everything, there's pros and cons to everything. And as Depeche Mode said, for those of you who might still remember them, everything counts in large amounts. So carbon is a greenhouse gas when it's carbon dioxide, and it just keeps heat in the atmosphere. And we need some of that, but our numbers are getting a little high. So we're looking at, what is a ton of CO2? Because that's what we're going to try to save. How much carbon can you save? And if you're looking at a metric ton of carbon dioxide, it's an invisible gas. So and I like this visual, it's about one hot air balloon full of gas. That would be 1 ton of CO2. And then you might hear the difference between carbon dioxide and carbon dioxide equivalent. And the reason why is that there's multiple greenhouse gases. There's methane, there's nitrous oxide, there's carbon dioxide, and there's a couple other ones in there. And what it means is they put it all on the scale of how does it compare to carbon dioxide in the atmosphere for holding down heat. And carbon dioxide, let's say, is 1. And then if you look at methane here, it's around 25, a little plus or minus, the equivalent of, it's more potent than CO2 by 25 to 30 times. And nitrous oxide is like 265 times more potent. So I kind of like looking at our nitrogen fertilizers and making them more efficient, because they'll have a big bang for the buck. Now we can look at how is the US, where does our carbon emit, where's it emitted from? What industries? And if you look, transportation is 29%, electricity is 25%, industry is 23%, commercial and residential 13%, and agriculture is about 10.5%. Agriculture emits 10% of all the emissions in the US are from ag. And let's look at how that's kind of broken down. Most of it is how we manage our soil. And we'll talk a little bit about that, like tillage releases carbon dioxide, cow burps, that's one. 28% is from our cows. And there's a lot of research going into how to bring this number down for cows and try to make a carbon neutral cow. And, a lot of research, adding seaweed to their food, just different things. And then there's manure management. So these are the ones that we can really control. The other is talking about rice production, urea fertilization, liming, and burning residues. So organic matter, you may hear people say soil organic carbon and soil organic matter, and they're kind of used interchangeably. And the reason why is because our organic matter is about 55, 58% carbon. So researchers will look at the soil organic carbon, and Anna did a nice explanation of this yesterday when we did this talk, is that when you look at soil organic carbon, it's harder to quantify and costs more to do so. So researchers will look at that number, but it's much more accurate than when you send it to a lab to look at soil organic matter. It's an easier test, but not quite as accurate. So for research, we really look at soil organic carbon. The neat thing about carbon is it's dark in color, black, and so you can actually see it in your soil if you have more carbon or less carbon. So when you're looking at those shoulders out there and they're tan in color, they have less than 1% organic matter. And all the way up to the darker colors of our soil are 3, 4, 5, even some of you may have 9% organic matter. And you could tell just by looking at the color of the soil how much carbon you already have. Now, the more carbon you have in your soil, the harder it is to change it. Okay, it's going to be more buffered. So we talk about which fields should you pick to put into the markets. I would suggest that you pick the fields that have the lowest carbon content or the lowest soil organic matter content in your trouble fields, because you'll see more of a change in those than you will in the ones that have 4, 5, 6% organic matter. And, you know, we're pretty blessed here in Minnesota. This map shows the organic matter content in the US. And Minnesota, Iowa, and Wisconsin has some of the highest organic matter levels, and we have some of the best soil in the world. And there's a lot of benefits to that, but one of the small things is our soil isn't going to change very quickly to improve that organic matter content to make it higher. Let's talk about carbon as a bank. You have your deposits into your carbon bank, and you have your withdrawals. And when you're looking at your deposits, you're looking at your crop biomass, because biomass is, when you look at dead residue, you know, the brown stuff laying out there, that's about 45% carbon sitting in there. So that's a deposit. And crop roots are great at getting carbon into the soil. Manure and cover crops both have a high carbon content in them. And these are wonderful ways to build your bank. Now, the ways that we take away from that or withdrawals is erosion, because you're just physically losing the soil away from there. Tillage, and tillage releases carbon back up into the atmosphere as CO2. And baling and burning. Burning will change that residue. Actually, you'll lose about 90% of your carbon as CO2 when you burn your residue off. So that should be used only in extreme times, you know. And then we also have harvest, which I use a green arrow because that's what we want, right? We want to harvest that crop. And when you take off corn, that has a lot of carbon in it, the ear. And when you take off soybeans, anything that we take off actually takes a lot of carbon away from our microbes. And I put that in red and green because we control some of it and we want some of it, but we don't want a really fast, high burn or high respiration rate. So one size is not going to fit all. And this is based on how much biomass is created out there, yield, and our temperatures. You know, as you go further north, we just have less ability to get high biomass. We have less rainfall and we have cooler temperatures. And so when you look at the carbon, people are asking, well, you know, how are the companies doing this? Are they just kind of greenwashing this? And you'll really have to check into the company that is buying these credits. So they can inset or offset. An inset means that they're going to change things inside their own buildings and things that they can directly control. So like IKEA is going to use more electric delivery vehicles, or they're going to use more recycled products or things like that. And some of them cannot get to their carbon goal without buying credits elsewhere. So if you think of like Shell, who, you know, is fossil fuels, how are they ever going to mitigate and get to carbon neutral when they produce fossil fuels. So they will go and buy credits, and it could be in putting in forests, or it could be to our farmers to capture that carbon into our soil. And that's called offsetting. And again, each company is going to be different on how they view this. And so if you want to sell your credit, make sure that it's to a company that you think has your ideals. This is one of the reasons why, it's just not going to be one size fits all. We have the climate differences and things like that. Now, Indigo gave Anna and I a kind of an example of what you could expect across Minnesota. So here down at the bottom, we have Blue Earth County, we have Swift County in the middle, and then we have Polk County up here. And what you can expect to get is that if you go from conventional tillage to vertical tillage, and you're in the north going down to the south, you can expect less of a carbon capture, about 1.5 or 0.15 carbon credit per acre per year. If you go from conventional to no-till, it about triples. And then if you add a non-legume cover crop, say cereal rye, and if you add a legume cover crop, you get a little bit more of a credit there. And if you're in an irrigated system, these numbers would be higher. Now, if you're going to look, well, what does that mean for what you're going to receive is, okay, let's say we're in Polk County and we're going to go to vertical till and we're going to put in cereal rye. Well, if your carbon credit's $15, then you're going to receive about $4 a year per acre on that. And as you go further south, you will receive more, a little bit more. And Anna can talk about how much carbon can we realistically expect to be able to get in Minnesota? And it's pretty interesting. Now, putting all the carbon credits to the side and the markets, our public perception has changed on how they look at food. And they would like to have input on how our food is produced, and understandably, but you need to be part of the conversation as well. You need to let them know what can realistically be done out in our fields and how, and come up with different ideas. Because one of the things I think in the markets that I would hope would change is all they're giving you credit for right now is putting carbon into the soil, right? And holding that carbon down. And let's say you're doing 2 less passes with your tractor. Well, they're not giving you credit for the emissions you're not emitting, from the tractor. They're only giving credit for capture, not for emissions. And I think that would be something that could change, and we can quantify that so much easier. There's a lot of data about how much CO2 and greenhouse gases are coming out of tailpipe.
Yeah, thank you, Jodi, for laying that groundwork and giving us a little more background and what can be kind of more of a complex type subject here. But Anna, maybe if you want to share some of your thoughts and maybe talk a little bit about some of the work that you've been doing around this too.
I'm actually going to share this platform that talks about work that a lot of people have done over the years, because one of the issues I think with carbon is that we get different stories from different sources about what's possible in terms of sequestering carbon in the soil and what our cropping systems might do. I really like this platform that the Nature Conservancy put together. It's AgEvidenceorg. So the way it works is they've collected the data from a whole bunch of different studies across the Midwest. You can see the little numbers on the map show how many are from each location. I don't know why we have to share our studies with Iowa there. Maybe those are studies in both states. So as you can see, there's a lot of research going into this platform. What we're talking about today is climate mitigation, but you can also look at, what's the effects of cover crops on pests, or what's the effect of nutrient management on soil nutrients or water quality. They're looking at different environmental outcomes of different agronomic practices. So, for example, tillage, Jodi talked about, actually didn't talk about tillage too much this time, but we sometimes talk about tillage as a way to decrease carbon emissions or keep carbon in our soil. And this breaks down some different measurements that researchers have done in tillage studies. You can look at carbon emissions. That would be the microbial respiration from the soil, carbon dioxide coming out of the soil as microbes break down residue. You could look at carbon storage. That would be looking at carbon before and after a change is made in tillage practice, or with side-by-side plots that are either tilled or not tilled. Or you could look at nitrogen emissions, and that gets at what Jodi was talking about in terms of nitrous oxide being a really potent greenhouse gas. And so the way these figures are set up is that if the black line is on the green side of the graph, that means that overall we see a favorable change. So from a difference from conventional tillage to reduced till system, in this case, I think they are lumping reduced and no-till studies together. We have a mean change, a small favorable change because it's on that green side of the line. But one thing that's interesting with this website is that, sometimes you're going to hear a story that's like, there's a huge positive change. And maybe that person is looking at data from a study like this. Or sometimes you're going to hear there's no change, or a tillage, reducing tillage actually increases your nitrogen emissions and contributes to climate change. And maybe they're looking at a study on this side of the line. So in all of these things, it's important to remember that sometimes people are reporting the average, sometimes people are reporting the results of a specific study, and there's going to be quite a bit of noise around a lot of these practices. So I won't go into any of these specifically, but if you want, you can click on just the Minnesota ones. Maybe you're tuning in from Iowa, you're more interested in what's going on down there. As Jodi pointed out, there are going to be climatic differences in how things are playing out, because it's so dependent on how much biomass is produced. So that's one piece I wanted to share. And then I was going to go into some of the measurement techniques around soil carbon that might explain why there's some noise around that. So one of the big things with measuring carbon in cropping systems is that we often don't have access to a starting point for the study. So I know that probably in this group, there's some people who have been no-tilling for 30 years, but if they don't have really precise soil samples from the beginning of their no-till experiment, we can't really know what the change is. And so then sometimes what we do is we say, well, this guy's been no-tilling for 30 years and the fellow next door has been using a moldboard plow or a chisel plow for 30 years. So let's just see how they compare to each other, which is higher than the other. And when you do that, you can end up saying like, okay, this yellow dot is higher than this blue dot. We have more carbon in the no-till system than we do in the conventional till system. But we don't know, if we haven't measured a starting point, whether perhaps they're both losing carbon, whether perhaps they're both pretty much stable, or whether perhaps that yellow dot represents an increase. So if we had measured 30 years ago, we would know with certainty that yes, no-till had increased that carbon. But otherwise, we don't necessarily know that a side-by-side comparison shows an increase. We just know that there's more over here, but maybe they were both losing, and it's just that one lost less. So that's one thing that I look for when I'm looking at these carbon studies, to see, okay, did we really see an increase in soil carbon in the soil? And that's a big reason why companies are not looking back at practices that have been in place for a long time. Biophysically, when I think about the whole carbon system, almost certainly that carbon is the no-till that's been in place for 30 years is still positive for soil carbon. It almost certainly is. But because they don't have that starting point, that's a big reason why the carbon markets are often requiring people to put in a new practice in their field. For people who have been long-term on no-till or other practices like that, what the reps have said to me when I've asked them about this is that there's little tweaks you can do. You can add a cover crop, you can add a different species of cover crop, you can get something more diverse, you can do things like that. You can add perennials. So there are directions to go if you're a long-term no-tiller, but they're almost all of them are pretty stringent about starting something new.
That's really interesting, Anna and Jodi too, and just thinking about that. So what does the research show? Like, okay, a farmer in Minnesota, because again, we're looking at University of Minnesota, of course, not ignoring other states here too, but again, I'm just thinking about a farmer in Minnesota. What practices could they realistically do, that have the biggest impact? Do you have some comparisons between like reducing tillage or adding a cover crop or manure, or, just what ones have the bigger impacts there?
I think that little chart that Jodi showed right off the bat about the difference between, let's see, I think it's just back here, a couple slides. Yeah, this one. Looking at the difference between changing from conventional to vertical till, there's a small increase or a small expected carbon credit, If you go from conventional to no-till, there's a larger expected carbon credit. And there's also a little bit larger expected carbon credit from a non-legume cover crop. Or no, these ones are pretty even. The legume cover is greater. That's what I thought. And I think the legume cover is greater for a couple reasons. One is because you are going to have to plant it earlier. So you're going to have more coverage over more of the year. And then also there's a question in here that has to do with the labile residues of cover crops. And there's some evidence that shows that crops like a legume, which have more nitrogen in them, get into the microbial biomass faster. And when the microbes have that biomass, when they're building their bodies, that's more likely to become stable carbon over time.
No,
Jodi,
the
would
one
you add anything about those
okay.
practices?
Yeah, when you're looking at just carbon, it's pretty limited. But if you look at improving your soil structure and getting better water infiltration and getting more resilient soil, carbon just kind of falls to the wayside. Why we can't build carbon very quickly, we can change our soils within a few years. And actually water infiltration can increase the next year when you have standing stocks out in the field. And so, you maybe look at adding a government program with it, like EQIP or something, so that, you can get more bang for your buck if you're going to try these new methods.
Well, and one question, we've done a lot of work with cover crops. Do you have a feel for what level? Because of course, we all know, we've seen sometimes you can get a really nice take cover crops and other times you just got a few plants out there. If you have just a few plants, is that having an impact? Is there a measurement of what kind of level we should have? And do these markets take into account, what your stand is of a cover crop when they're looking at credits?
I haven't heard of anybody who's ground truthing your cover crop biomass. Have you, Jodi?
Nope.
So basically, if you're have it out there, you'll get the credit, but not sure on the.
And that's one thing that farmers need to be very careful on is if you're look at the contract, also always have a lawyer help you with the contracts. If you look on the contract, does it say that you're responsible if your carbon doesn't build? Because you could have these weather issues where your cover crops just didn't really do what they should do, or that we hope they would do. Be very careful on the sign up for this.
Well, and we're getting a couple of questions, but I still have a question that I want to ask you too. So let's say somebody gets into this, they do a practice. What if all of a sudden they say, I've had enough of this, I'm going to, till my soil this year, or something happened and you have to do tillage for one reason, or you decide you want to do tillage. Are you going to wipe out all your benefits from that, or how much of an impact? Do we still have some carbon storage in there, or other benefits?
Well, look at your contract. Some of them say that due to weather and things out of your control, that you can miss that year, but you won't get paid that year, and then you can put it in the next year. Double check on that. But if you were going to put in cover crops when you took out wheat, and then next year you're not even going to be in wheat because now you're, so the next year you're going to beans or something, then, be careful with that, because you may not be able to get the cover crop back in like you had put on your contract. And there was some other, go ahead, Anna, my brain.
Yeah. Well, I was going to say that from the contract standpoint, Jodi has it just right. And I think we'll have a reference to this, this piece that the Iowa State folks put together that compares the different markets. And it specifically asks that question: if you fail to deliver on the practice you signed up for, what's the consequence for your contract? So that's one thing. But I think your question was also, Liz, like, are you actually sequestering any carbon?
Yeah, I'm thinking the science. Sometimes, people might say, well, are these markets a little bit the, cart before the horse? What's the science behind this? How long, if I do no-till for a while because I'm in this contract, then all of a sudden I'm like, well, I'm going to get out of this. And if I did aggressive tillage, would I lose all those benefits? Again, looking at the whole big picture perspective.
Yeah. A single tillage pass does have an effect on your soil structure, and it's going to release a bunch of carbon right in that minute, and it's going to change how your soil has capacity to hold carbon if you destroy soil structure, because soil structure, soil aggregates are kind of where the carbon hides from the microbes, if you will, and protects it from fast decomposition. So it's just a balance though, tillage 1 in 3 years or something like that is certainly better for your carbon and your structure and all of your properties than tillage every year. So you are gaining something and then you lose something, and you gain something and you lose something. As with most choices on your farm, there are some trade-offs. So from the biophysical standpoint, it can be pretty mixed up, and it'll depend on the conditions that year too, in terms of whether you're tilling at a time that your microbes are going to be really active, and also what crops are going in the next year, whether you have living roots in the ground from a cover crop. I would say it's an open area of investigation, because in science, as you know, we like to measure one thing at a time. And so we just do tillage. We don't do tillage and then no tillage and tillage and no tillage. We don't go back and forth very frequently. That takes a long time to measure the effect of it. We don't have great data on it.
Yeah, and going back to contracts, look at your exit clause. Say that, okay, I just can't make this work. It's make sure you can get out. The other thing is when you're looking at contracts, a lot of them, if they're short term, like just a year or 2 or 3, I just don't even know why they have those. You're not going to see a change in carbon at all. And if you look at the longer ones, so 10 years plus, the thing about that is make sure that if the price of carbon goes up, it's also in your contract that yours goes up too. Because in 10 years, things can change drastically.
I put a link to the ISU. Rick, maybe you can see that says that link is blocked. So I'm not sure what's going on there. We'll see if we can figure that out. But anyway, here, I'll hit some questions here. We have a question from Andrea. Said, what is more important, the residues of cover crops whose organic matter presents high rates of mineralization, so high proportion of labile organic matter, or residues that provide a high percentage of stable or recalcitrant organic matter?
This is a good question. It's one of our hot topics in the carbon cycling research world. So when Andres brings up labile versus stable or recalcitrant organic matter, he's talking about how easy that organic matter is for microbes to break down. And, you could think of it in terms of human food instead of microbe food. Is it easier to eat ice cream, or is it easier to eat a big bowl of kale salad, right? And, they have different effects on the system. I call it for my kids short energy and long energy foods. And for the microbes, it's similar. Having a little bit of that short energy labile carbon is good for them to get jump started. That's why people have tried to apply things like molasses to their fields. It does jumpstart the microbes. It's just unlikely that you can apply it at a high enough rate to really change your long-term microbial function. So that's my opinion on molasses on your field. But getting back to your question, you do want some of each, just like I tell my kids, you got to eat a little bit of vegetables, a little bit of fiber to have that long energy aspect. And you want a little of the short energy stuff too. When you're thinking about your cropping system, and you've got a corn soybean rotation, say, I know there's quite a few farmers with a corn soybean rotation in Minnesota, so that's relevant, but your corn residue is already providing that stable, recalcitrant, hard to break down, fibrous vegetable matter. And so a little bit of something juicier that's a younger cover crop residue, that's going to be good for the microbial population overall. It's good for that balance. With soybeans, where you don't really have as much residue, maybe you want to look more at getting something like a grass that has a good amount of higher carbon to nitrogen ratio biomass. That's one way that we think about easier or harder to break down, is how much nitrogen there is relative to the carbon in the biomass.
And I always think of this for people who rake their leaves. If you have a dry pile of leaves, do they decompose very quickly? No. So what you want to do is add your kitchen scraps or nitrogen and water, and they'll burn up pretty quick. And so that's your microbes kicking in. They got everything they need then. And so that's the same in the soil with our residues with high carbon versus residues that have low carbon.
Right. And I'm glad you brought.
Oh, manure has both.
Yeah. Yeah, manure does have both. And I'm glad you brought up moisture, because the question asks which is more important, these essentially juicy residues versus more crunchy residues. And it really depends on the water status, right? Maybe if it's drier, you can't get to that crunchy stuff and you need the juicier stuff. But maybe if it's plenty moist, you can really get to the crunchier stuff more easily. And so just like with so many things with farming, if we could predict the weather, we could really manage really well. And that's the case with carbon management too.
And I'm sure that plays a role in why we see differences when you look geography wise too across the nation and everything too. Here's another question about, does peat ground hold a lot of carbon? So are there opportunities to take peat ground out of production, or is it more important to spread out carbon holding practices across many acres? So basically it's could tie with, do you want to have a targeted, I'm assuming I'm kind of rewording this, but yeah, more of a targeted type thing to some of these areas? Could we have more impact potentially?
I have a slide on that from our Minnesota kind of summary of the effect of different practices on ag land. Can you see this now?
Yes.
Yeah.
This was from my colleagues Jess Gutenecht and Jake Youngers. And what they did was they estimated what our emissions reductions after 10 to 20 years, so long-term emissions reductions of different ag practices performed on half of Minnesota cropland. So this number represents how many millions of tons per year we would see after 10 to 20 years if we did this on half of Minnesota cropland. And I just bring this up to point out that all these in-field practices, cover crops, tillage, putting a perennial like alfalfa in rotation, converting to perennial forage, those are much smaller than most of these retirement options, retire land to forest, retire land to grassland. And then wetland is also pretty high up here. Sorry, I also didn't point out that the yellow bar here represents the soil carbon change from these various practices, and the blue represents the emissions reduction. And actually that points out an interesting trade-off to something like wetland and peat, where you do have significant nitrous oxide, methane emissions from that area that doesn't have any oxygen. So those other greenhouse gases tend to be emitted more from saturated soils. And so a wetland or a peat area is going to emit more methane and nitrous oxide, but also has high carbon storage potential. So you see it kind of ends up in the middle, where it's pretty high on the carbon storage, but not great for reducing other emissions in the system. So peat is a great thing. I don't know how we can, increase peat on the landscape. Developing peat is a long-term prospect, as with everything with soil, but maybe in particular.
Well, and that graph is interesting. If you could pop that up there again, because it's saying on half of our acres, right?
Mm-hmm.
Whereas what percentage of our acres now have cover crops? Maybe 5% or 5%. I don't know what the percent in low tillage perennials. So I guess it's looking at potential, but so that's interesting to look at that. And
but it also shows that not one way is going to make our emissions, that we need multiple different prongs on this. And one of the ones I'd like to see is I like the retire land to forest, but I'm not talking the whole field, like out in West Central Minnesota. I'd like to see more windbreaks and shelter belts go up, just because I look a lot at erosion, and I'm tired of cleaning my house windows. And
yeah, you can really see that this time of year too. I've been driving around, and you see the black snow that's still out there, and it's like, that shouldn't be black, that was topsoil.
And remember, if it's black, that's carbon.
Yeah, so strategically placing like windbreaks and that's very good. Good point. So on this, sorry, did you want to say something, Anna?
Well, I was just going to point out, maybe you were too, that somebody had a question that came in the chat that asked if the restored grassland in this slide was grazed or not. And this is not specific to one study. This is pulling together a lot of different evidence for increases, but it's true, as the questioner probably knows, that grazing can have an effect on how much carbon is stored in a grassland, and generally well-managed grazing is positive for soil carbon.
And kind of related to that, they're wondering, we have another question here too, if you could discuss how nitrous oxide is produced by applying nitrogen. I don't know if you get into this here, but is this formed in the nitrification process, and is it less if the N is under the soil surface? So,
well, I do a lot with that with tillage. And then when people say, should I tile drain or not? Tile drain does help out with, it gets more and more saturated. We usually have microbes that like oxygen. They like free oxygen. And so, you know, they're going good. But as those pore spaces fill up with water, you start getting a shift into anaerobic bacteria that will take oxygen from different sources, not free oxygen. So when you have nitrate, which is NO3, which means one nitrogen, three oxygens, they start taking off that oxygen. And when they do that, it goes from nitrate to nitrite, NO2, and then you take off another oxygen, then you're at NO, and then N2O, and N2O is a gas, and that's one of our greenhouse gases, and a gas in the soil means it goes back up to the atmosphere. So I don't like seeing saturated soils out there because you can lose 2 to 4 pounds of nitrogen per acre per day in those saturated soils, and nitrogen's too expensive to lose right now. So that's part of it. And then Anna, do you have any more to add for, you know, we're trying to keep it an aerobic system, free oxygen out there.
Yeah, just that this person brings up nitrogen placement. I don't know if you would add to that too.
Okay, anytime nitrogen's on the soil surface, you can lose it. Usually on the soil surface, though, it's going to be N2 gas, not N2O. So that's volatilization. And what's interesting about nitrogen is almost the whole nitrogen cycle is run by microbes. I think we all should get up on microbes a lot better, except for volatilization. I'm going to get all mixed up without. What else do I need to add to that, Anna?
No, I think you got it. It's just more
Okay.
vulnerable on the surface. Once it's in the soil, it's more likely to be going into those microbial bodies. And, you know, what they sometimes call immobilized in microbial biomass, which means it's not available right now, but when that microbe dies in a week or a month, then it'll be available.
Yeah, then it's mineralized back out. So you got it immobilized into their bodies and mineralized back out to the soil. Again, run by microbes.
And a very complex system as well.
Yeah.
And we just had a comment here. Well, a question on that related back to that graph about, does a chart showing the effect of removing 50% of Minnesota ag land from production also include the impact of the resulting population decrease? Yeah, I mean, obviously we cannot have 50% of our ag land go out of production and not expect any input, you know, impacts on food production. So
you just have to pick a point and yeah, go with it on those.
I think that's just kind of showing what potential is there, but yeah, there's a lot of impacts to that as well.
It is not the university saying, hey, we need to take half of our
Yeah.
land out of crop production. That is not what it's saying. It's a model to show what our potential.
A thought experiment. How, you know,
right. Yeah, because 50% is a huge amount. Yeah.
Right. And I think that it's a fair point. Jodi started with those pie graphs of different kinds of emissions. Changing agricultural practices is so complicated. It has this whole system associated with it. Jodi and I hope that you are motivated to change agricultural practices for improved soil structure, for better water function, to reduce erosion. But in terms of changing our carbon footprint as a species, there may be easier ways than changing our agricultural production system.
Mm-hmm.
Yeah, maybe go more towards the lower hanging fruit here. We have some questions about the markets for carbon credits here. One of the questions, does anyone have insight on how much these large companies are paying the brokerage firms for carbon credits compared to what the farmers are getting? So basically looking at the farmer payment percentage versus what companies are getting.
Yeah, they're getting a cut. I'm not sure, but
free.
No, but what Anna and I have also been seeing is more places are trying to start up farmer-run brokerages so that the farmer is in charge of producing that carbon credit and selling it. And one of the benefits to that is I've been talking with the corn and soybean growers, and what they're concerned about is, okay, so they sell all these millions of acres of credits to Microsoft, IKEA, McDonald's, whoever. And then down the line, people will say, okay, now farmer, you need to prove to us you're saving carbon. And it's like, but we are. but they sold the credit. They don't get the credit for it. The person who bought the credit gets the credit. So what they're trying to do is make their own brokerages where they get the credit. Farmers will get the credit for holding down carbon, and they can sell that credit. So be careful where that credit's going.
It's very interesting too, because, well, I shouldn't get on my soapbox, but it makes you wonder what the company's doing otherwise, you know, asking farmers to do these practices. You know, you got to evaluate what has the biggest impact, I guess, overall too, right?
Right. And there's differences between how much they can offset and inset, depending on the company. Like I thought McDonald's could inset a lot of it, you know, change light bulbs, change whatever in their areas because they have so many stores. Well, they can, but over 90% of their carbon emissions is actually their supply chain. And so that's offsetting, like cows burping. And so they will need to offset their credits to change that supply. So every company is different. You know, I thought it was a little more black and white. It's not. Nothing is.
That's interesting. Yeah, we have another one here. Why would a company buy carbon credits from the market to inset when they could just use their own money to buy, say, electric vehicles? That's probably getting beyond soil health conversations, but
they're looking at multiple ways. It's not just a one-pronged approach for companies or for farmers or anybody. They're just looking at a lot of different ways. I'm sure they're looking at the low-hanging fruit too first, and then they'll be going to the more expensive ones. Now there's machines out there that can pull down carbon from the atmosphere and put it into the soil deep into the earth, and that costs a lot more than $20 a carbon credit. You know, so our carbon credit's going to go up in price as these companies get closer to their goal dates. Yeah. How much? And that's anybody's guess.
interesting. And how long are these agreements typically again? Just curious. I know you probably said that, but I suppose it varies.
5 to 10 years.
5 to 10 years. Okay, and we do have one here now. When dealing with manure application, which is a better option, to disturb the soil in order to incorporate the manure or leave it on the surface for the end to volatilize?
Put it down. Put it under. You don't want to lose the nitrogen. You don't want to set up polluting, you know, or losing nitrogen and your nutrients off the field. And you also, you know, neighbor relations, put the manure down.
Does that include during winter time when the soil is frozen?
You're not supposed to put it down then.
Sorry.
Great question, Liz.
Yes, yes.
Is that not a, if you, yeah, not a good planned practice? Okay.
No, you know, see, it's always a balance. It's not just, am I saving carbon? It's all the other things that are related to it as well. You can put a manure out on a frozen field, and one, you have less compaction and you can see your spread pattern a lot better, but you're going to lose the nitrogen. You're going to, and all that work that you, and fuel and stuff and time to put it out there is going to be wasted. So definitely put it under. I used to do manure management, and yeah, put it down. I mean, get the value, especially with the price of nitrogen right now.
Right. Yeah. We have some more questions here on, for some companies, purchasing credits is a way to close a stubborn gap towards their reduction goals when other methods have been exhausted. I guess that's more of a comment there. But we do have a question here too, the wondering about corn-based ethanol and net carbon emissions in agriculture. So over 40% of corn in US today goes to ethanol. So is this really a good process for, you know, CO2 control? That's a big issue too. But I suppose looking at the balances between ethanol, is there a net reduction in emissions? Maybe this is getting around that as well. I don't know what the current status is on that research, but if you're familiar with.
Yeah, I don't have those life cycle numbers in my head. I don't know if you do, Jodi.
No, but the corn growers, there's that publication that they talked about yesterday.
All right, we'll see if you can find it. I did want to say something else about that. So our research shows that growing corn for grain tends to be about carbon neutral. Corn has so much biomass that you do put a lot of residue into the soil. You also take a lot off with the harvest, and because of the microbes, as Jodi pointed out. So just growing corn tends to be neutral. I feel like where our system, where the corn really gets into trouble is when it goes to feeding animals, because then it's contributing to the cow burp side of things that Jodi brought up. And that's why you're seeing so much press right now about reduced meat consumption and that kind of thing. And that's why it is important to think about, whether using grasslands to feed animals, grazing animals on croplands, things like that, if they can help reduce the overall carbon footprint of agriculture. I don't know about the life cycle specifically of ethanol, but the corn system, it's feeding a couple of different systems where the life cycle analysis involves much more than just the tractor, the seeds, the corn in the field.
Okay, and it's building the evidence on corn ethanol's greenhouse gas profile, and it's from the USDA. And the corn growers gave it to us yesterday, so I haven't had a chance to read it yet, but the link is in the chat.
And we had a question in the chair. Soybeans are a carbon negative crop, ? Have heard this stated, and it seems to make sense, but.
Okay. So maybe I should show the Gamble slide because that kind of covers both this and the last point I was making. So this is some research from my colleague at University of Minnesota. It's done at Rosemont and at a dairy farm, I think near Morris in west central Minnesota. And they measured the carbon going in and out of the system between 2007 and 2015. So these numbers represent the average of a bunch of years. And let's see, I wanted to show this. So a carbon balance represents kind of like the bank account figure that Jodi was talking about. Taking your inputs, which are photosynthesis, the plants sucking carbon from the atmosphere, and your outputs, which are that microbial respiration, carbon dioxide released from the soil. And you subtract your outputs from your inputs, and you could do that every day, because every day there's carbon coming in through the plants. I mean, not on a day like today because it's too cold, but there's not much respiration on a day like today either. So you could do that every day, say how much carbon comes in or how much carbon goes out, but often people calculate it annually. So they say how much carbon is coming in over the course of a whole year and out from respiration. And so that's what this study did. And they looked at several different crops here. And so they compared alfalfa, grain maize, silage maize, and soybean in each column. And the blue bars represent the carbon coming in, the gained or the inputs. The yellow represents the two primary sources of loss from the system: harvest in the lighter colored yellow, and soil respiration, that's the microbes breathing out carbon dioxide, in the darker orange. And then the red bar, they call it the net. So that's the balance. They took the blue, they subtracted the yellow colors, and they got this red. And so if you look across different crops, one thing that jumps out, the person brought up soybeans, and soybeans do have much less productivity than these other crops, which makes sense. You've got alfalfa growing all year. Every time you cut it grows again. You've got corn producing, obviously much more biomass than soybean. And that does lead to a slightly negative carbon balance for soybean. So you've got still pretty significant respiration. You've got some harvest carbon removal. And so you've got negative carbon balance overall by a little bit. It's actually pretty similar to alfalfa because you harvest so much alfalfa of that productivity. One thing alfalfa has going for it is this lighter blue bar I didn't mention is a manure carbon input. They measured how much carbon was in the manure that was applied to that alfalfa field. Go ahead.
Oh, well, Anna, so when I look at this would tell me that we're losing carbon in all of our systems. And yeah, I mean, in long term, is this, you think, more of a snapshot? Because I mean, do you think when you look overall that we're truly continuing to lose carbon in and yeah, that would just say, well, if we kept doing that, that would not be a good thing then.
Yeah, well, if you look at grain maize, this overlaps with 0. So it's a slightly negative number, but it overlaps with 0, meaning I consider that grain maize number basically a 0. And then from year to year, it might bounce up and down a little bit, depending on productivity, how warm it is in the fall, so how much respiration there is. I do think that we are probably at 0 at best and probably slightly losing carbon annually in many of these systems. And so when I look at the models that show potential for gains, for carbon gains, I'm pretty skeptical. If anything, they're going to be small and slow because we're kind of, I think my measurement slides are back here. I think we're kind of, I'm pointing with my finger, not helpful. I think we're kind of somewhere here where we're like losing real slowly on our long-term trajectory. You know, maybe we were losing this fast right after the prairies were first plowed. That was a big loss of carbon. And now maybe we're just kind of down here with real slow losses or maybe stable in some places.
And the question is, does that include carbon emissions for crop inputs? I don't know if you have that in that calculation or not.
No, and that's why, you know, that's what we want to have start being covered, is that you're not emitting as much when you're using different cropping systems or different tillage systems. And that's not given credit yet.
Yeah, that's a great point.
Yeah, if you think about this balance, you know, this particular balance is looking just at what's in the soil. So it's looking at your field, maybe it's going a meter down. That's another question. How deep are you going? But it's looking at a physical in and out location. Whereas you could do more of what we call life cycle analysis and think about how much carbon went into the fertilizer on that corn and how much carbon is used in fuel and those kinds of pieces. Those kinds of pieces, you know, we all have a carbon footprint in that way. A farm is no different than any of us.
I do have a question related to this, but I'll hit one question here that came up again too. And I'm not sure if this is getting out of your wheelhouse here, but doesn't feeding distillers grains result in less animal emissions than feeding straight corn due to reduction in starch in the rotation or in the rations, excuse me. Yeah, I'm not sure.
That would make sense, but I'd have to go check it out. I mean, if it does have less starch in it, you know, the more sugar or easily broken down sugars are there, then the more they burp. So like cows that are fed corn grain versus pasture or, you know, grass fed, they will actually produce more burps. But on grass, sometimes it takes them longer to finish out. So they're living longer. So again, it's always this balance. The DDGs, I'd have to go look up and see. Anna, have you heard anything about that kind of feed?
No, okay. No, I haven't done that work.
And then you also got to look at the carbon balance of that, of taking it from the ethanol plant and giving it right to the cow versus how the other feed is produced and given to a cow. I mean, it's the university answer. It depends.
Yeah. Well, and I think the markets are mostly focusing more on this kind of balance inside the field and not the farm scale balance.
And a question related is, with grazing livestock to the system potentially help the end carbon numbers? I suppose you're getting more manure back into the system, and
when you don't have to transport the manure out to the field. You don't have to store the manure. There's a lot of benefits to that. So again, looking, and I think Jess Gutnick, she's on some of these studies that Anna has out, is looking at the whole farm carbon look there. Because emissions is just as important as capturing.
Yeah. This is some long-term data from Wisconsin showing how systems changed over 20 years. This is in southern Wisconsin, so a little bit different, but they had 3 different cash grain rotations, 3 different forage rotations, so corn alfalfa rotations, and then a rotationally grazed pasture. So obviously a really different system, and doesn't address the question of grazing livestock in your cropland. But when you look at the top 15 centimeters over 20 years, the pasture gained a little carbon. And if you look at the 0 to 90 centimeters, so about 3 feet deep in the profile, you see that the pasture is holding its carbon or maybe starting to gain. Again, we overlap with 0, so as scientists, we interpret that as 0, whereas the other 2 systems were losing. So grazing on pasture does seem like the best bet we have to maintain and increase carbon.
Here's one more question that popped up too. Do they have charts showing change in carbon for corn, soybeans, and if using cover crops?
So this shows 2 different ways to think about the carbon from cover crops. This work is from my PhD and just emphasizes over the 3 years we studied it in southern Wisconsin again. The yellow bars are the corn total biomass, that's above and below ground, and the blue is the cover crop. And so there's just a lot more corn biomass than there is cover crop. In our best year for growing cover crop, we produced, maybe a quarter of the biomass that we're able to produce with corn. So it does do something, but it's going to be this sort of minimal piece of the whole picture. And this was a continuous corn rotation that was strip tilled. So we didn't have the soybean year where it might have looked different, where that cover crop contribution might have looked better.
Yeah, and that is one of our challenges too, is just getting enough biomass, with cover crops, trying to figure out the practices that'll optimize that the most. But so I have a just question. I see we're getting close to the end of the time here. So if you had a farmer that was interested in, say, looking at going to like strip tillage or looking at possibly doing cover crops or doing more perennials, and then you've got this carbon market stuff floating out there too, what would you recommend that they do? Should they try some of this stuff first, or is it best to try to get into a carbon market first so they can maybe take a benefit of that? Because typically, do they really pay you for something you're already doing? Do you have any recommendations or just kind of things to be thinking about with that?
I'm always the person, just put your toe in, don't jump in. So I would say start with your worst fields, the sandiest with the lowest organic matter content. One, even if the carbon markets don't pay out, you'll see other benefits for crop yield and things like that. And then double it up with EQIP or another one. As long as it's not a carbon government program, you can double them up. And I'd like to see them do that, and not the whole farm. Although I haven't met a guy who did the whole farm just recently. And I said, you did? And he said, yeah, because I was going to switch to all strip till anyway. And if I join in 5 years, I won't get credit for that. So he put everything in. And again, check and see if the carbon market goes up, do you get a piece of that in your contract? What would you say, Anna?
Yep, I agree. It should be something you wanted to do anyway. If you're gonna do it, if you're gonna add the carbon benefit and that's the only payment you're gonna get, because it's not gonna be enough to cover it. It's not supposed to be enough to cover it. It's supposed to be something you want to do anyway, and then you get an extra $5 an acre for it, which is just not bad. It's in the right direction, even if it's not very much. And totally agree with Jodi about adding other funding.
Yeah, the one thing I'm actually kind of worried about is farmers are going to stop doing these practices or not jump into them, waiting for the carbon market to go up.
Right.
And I'm afraid we're going to stay at status quo just for that reason. And
well, like we said, we only have about 4% adoption of cover crops, so we got a lot of land left to enroll in those carbon markets.
Right, and as we know, I mean, you've done a great job in all your work too, just talking about all the benefits that you can have from these practices that can help enhance soil health, like having more reduced tillage and adding cover crops to the system, or having more perennials. Again, just, I don't know if you want to share any thoughts on that as well too, but again, just kind of the soil health type benefits, reduced erosion, that's always been a big thing that you can just see that, but I don't know if you want to comment any on that as we wrap things up too, because like, what if the carbon market thing wasn't there,
Yeah, there are these other benefits. The one I've really focused on recently is water function. I got here in the winter of 2018, 2019, and people were really worried about being too wet. And it was a hard year in 2019 because of the really wet conditions. Cover crops can mitigate that to some extent. Good soil structure can mitigate that. Then we had a really dry year last year. And again, good soil structure can mitigate that because you've got areas that hold water for longer term. So that's a benefit that I really point to, because I think that's where you get the intersection of the environmental issues that society as a whole is interested in and on-farm logistical help for a farmer.
And you can go to the Upper Midwest Tillage Guide if you want to look at 20 years of research from North Dakota and Minnesota on tillage. We've overrated tillage.
Yeah, that's great. If you can put that link in there, Jodi, or tell them where to go, and I better wrap things up here. But yeah, so again, thank you to our speakers, and thanks to our sponsors, the Minnesota Soybean Research and Promotion Council and the Minnesota Corn Research and Promotion Council. And just a reminder, next week's session will be on biocontrol strategies to manage pests And also the last session that's coming up March 30th, we have just changed that slightly. It will be taming your soil fertility and weed management inputs as well. That'll be on March 30th. So again, everybody, thank you. Have a great rest of the day, and hopefully we'll see you next week.